We're supposed to determine the horizontal and vertical slant asymptotes. First thing you have to do is factor this. This is a trinomial. We're fortunate enough that the lead coefficient is 1, so this is the easy type to factor. You just need to make 2 sets of parentheses for binomials. The two numbers that multiply to get -6, the same two numbers add to get 1. So it's going to give us x plus 3 and an x minus 2. So anything cancel from the top and bottom? If it does, then that means there's holes. Nothing cancels. To find your vertical asymptotes, take your denominator, your factored version of it, set it equal to 0. Set each factor equal to 0. And you solve that, you get x is -3 and x is 2. Those are your vertical asymptotes. To find your horizontal asymptotes, you're comparing n to d. This is the unfactored version that you're comparing it. You're looking at the biggest exponent in your numerator, that's what n is, comparing it to the biggest exponent in your denominator. That's what d is. So, how does it compare? In this case, we have 1, which is less than 2. When that happens, then that means we have a horizontal asymptote at y equals 0. If you have a horizontal one, then you have no slant, because you can't have a horizontal and a slant. Number 2, if you try to factor this numerator, you will find that it doesn't factor. The denominator is just a monomial, so there's no factoring involved in that. So to find your vertical asymptotes, once again you take your denominator, set it equal to 0, and solve it. Vertical asymptote at x equals 0. To find the horizontal asymptotes, compare the biggest exponent in your numerator with the biggest exponent in your denominator. In this case, we have a 3, which is bigger than a 2. Whence, there's no horizontal asymptotes. If the top is bigger than the bottom, there's no horizontal asymptotes, which might mean there's a slant. To determine if there's a slant, n has to be exactly d plus 1. In this case, n is 3 and d is 2. Is 3 the same thing as 2 plus 1? It sure is. Therefore, we have a slant. To find it, you have to use long division. Take your numerator, divide it by your denominator. Notice when doing this, I'm missing a term. I have x cubed, then I have x to the first. I need an x squared in there. Need might be a strong word, but it should be in there. So I'm going to add to this a plus 0x squared. And however many times 2x squared goes into this evenly, I set y equal to that, and that's my slant asymptote. How many times does x squared go into x cubed? How many times does 2 go into 3? Most people have a hard time with that. All you have to do is take what you're dividing, write it over top of what you're dividing by, and simplify it. This is 3x cubed divided by 2x squared. I can cancel 3 of these x's and 2 of these. I said that wrong. I can cancel 2 x's from the top and the bottom. So that gives me on the top x. On the bottom, I got rid of my x squared. 3 divided by 2 doesn't go. So that means this goes into this 3/2 x times evenly. Then I take 3 over 2x and multiply it by 2x squared. 3 over 2 times 2 is 3. X times x squared is x cubed. I then change the sign of any terms that are in this row, and I add 3x cubed minus 3x cubed is 0. Or I should say plus a negative 3x cubed, either way. Bring down the next term. How many times will 2x squared go into 0x squared? In other words, what's 0 divided by 2? 0. 0 times 2x squared is 0. Subtract, it gives me 0. Bring down the next term. As soon as the exponent that you're dividing is less than what you're dividing by, then everything else is a remainder. Quite frankly, we don't care about the remainder. So the remainder is negative 2x plus 1. There's different ways to write this. Once again, that part doesn't matter. We just care how many times it goes into it evenly. So our slant asymptote is y equals 3/2 x. Y equals 3/2 x. Your slant asymptote will be a line, and it will be in slope-intercept form every time you get it. Number 3, if we factor this, the numerator has a GCF of 3, leaving you with x squared plus 4x plus 4. Denominator has a GCF of 5, leaving you with x squared minus 11x plus 30. Once again, we're fortunate because these trinomials, the lead coefficients are 1s. If they're 1s, it's the easy type to factor. I need 2 numbers that multiply to give me positive 4 and add to give me positive 4. Actually, this is a perfect square trinomial, so we could write it as x plus 2 squared. Or we could write it as x plus 2 times x plus 2, either way. The bottom, we need 2 things that multiply to give you 30 and add to give you negative 11. X minus 5 and x minus 6. Does anything cancel from the top and the bottom? Absolutely not. So to find our vertical asymptote, singular or plural, take your denominator and set it equal to 0. Set each factor equal to 0. 5 equals 0. No, it doesn't. It makes no sense. X minus 5 equals 0 gives us x equals 5. X minus 6 equals 0 gives us x equals 6. So we have 2 vertical asymptotes. X equals 5 and x equals 6. Horizontal. Take the non-factored version, which is this version here. Compare the biggest exponent in the numerator to the biggest exponent in the denominator. In this case, they're the same. If they are the same, let's go with a therefore. Y is equal to a over b. A is the lead coefficient in the numerator. B is the lead coefficient in the denominator. So y equals 3/5. It's a horizontal line at 3/5. If there's a horizontal asymptote, then there cannot be a slant. Question 4, you're supposed to relate these graphs to the parent graph. So this parent graph, which it doesn't matter to do these questions, looks something like this. Has a vertical asymptote at x equals 0 and a horizontal one at y equals 0. Doesn't matter. What does this minus 1 do to the graph? Translates it down 1. Same thing it's done this whole chapter. What does this plus 5 do to the graph? Well, that's inside the function. Translates it to the left 5. C, I'm going to come back to that because that is a bit tricky. So is D. E, this minus 3 takes it to the right 3, plus 7 translates it up 7. So we'll say translates right 3 and up 7. C, most people see this and they say, well, this is a 4. So it stretches the graph vertically by 4. Look closer. That is not a 4. I know, you're angry. This is actually, I think you'll agree, 1/4 times 1 over x. The 4 is on the bottom, so you're dividing by 4. 1/4 is 0.25. This is 0.25 times 1 over x. 1/4, or 0.25, is between 0 and 1. Therefore, this shrinks the graph vertically by 1/4. D, similar in its confusingness. This looks like it's a 0.2, but it's not. It's a 1 divided by 0.2. 0.2, the proper way to read it is 2/10, which is 1/5. So this is actually saying 1 divided by 1/5, which is actually 5. It's 1 times 5 over 1. You multiply by the reciprocal of the denominator. This is actually a 5 here. So this problem is actually 5 times 1 over x plus 8. It's actually 5 times 1 over x plus 8. This 5, or this dividing by 0.2, stretches the graph vertically by 5. The 8 translates the graph up 8. Five, 6, and 7, you're supposed to create a function of the form y equals f of x that satisfies each set of conditions. If there's a vertical asymptote at x equals 4, that means that you had to have an x minus 4 equal to 0 to be able to get that asymptote, which means the bottom of your fraction, oh, pardon me, the bottom of your fraction had to have an x minus, pardon me again, had to have an x minus 4 in it. So that's how you get vertical asymptotes. If you set x minus 4 equal to 0 and solve it, you get x equals 4, which is what that says. There's a hole at x equals 0. Holes happen when things are canceled from the top and the bottom. So an x had to be on the top and the bottom for those to cancel. Once they cancel, you set it equal to 0 and solve it to get your holes. Here's your function. You do not need to multiply it out. Number 6. I see vertical asymptotes and holes, so it's going to be a fraction. Vertical asymptote at x equals 5. That means x minus 5 has to be on the bottom of your fraction. Also a vertical asymptote at x equals 4. That means x minus 4 had to be on the bottom of your fraction. Let's put those in. And then here we have a hole at x equals -2, which means x plus 2 had to be in this problem. Because if you take x plus 2 and set it equal to 0, you get x equals -2. Holes happen when it's canceled from the top and the bottom. I didn't leave myself much room here. Let me bring this up a bit. So in addition to these vertical asymptotes, there had to be an x plus 2 in my numerator and denominator. Number 7, hole at x equals 4. That means x minus 4 has to be on the top and the bottom of your fraction. X equals negative 8, also a hole there. That means x plus 8 had to be on the top and bottom. It resembles y equals x. Well, we already got the y equals, that's f of x equals. X goes on the top of the fraction, because if it was on the bottom it would say 1 divided by x. So, that's it. Number 8, you're supposed to graph the rational function. To do so, we need to figure out where the vertical, horizontal, slant asymptotes are. It's already factored, nothing cancels, so there's no holes. We're going to have a vertical asymptote at setting our denominator equal to 0 and solving it. So at x equals negative 1, we have this vertical asymptote. To find the horizontal asymptotes, take our denominator, take the exponent of the numerator and denominator and compare them. See which one's bigger, which one's smaller, which one's further the same as each other. The exponents here, for the exponents, are a 1 and a 1, so the same. So n equals d. Whence is not a word, by the way, we have a horizontal asymptote at y equals a over b. A is the lead coefficient of the numerator, b is the lead coefficient of the denominator. So that's 1 divided by 1, which is 1. So we have this horizontal asymptote at y equals 1. Now we have to graph the actual curves. Let me show you your choices. And since this does not resemble a parent equation, we're going to have to use our calculator. If it did resemble a parent, we would just throw it up here. Basically, though, you got 4 choices. It's one of these combinations. Your curve is likely to be up here or down here, one or the other. Couldn't be both. And over here, it's going to be either up here or down here. So it's either, let's say, let's number these, either 2 and 4 or 1 and 4. No, it couldn't be 1 and 4. It's either 2 and 4, 2 and 1, or 1 and 3, or 1 and 2. It's one of those combinations. Once again, though, we're not equipped to handle that at this point, so we're going to use our calculator to do this. Please note your calculator will not give you the asymptotes. So if you pull your calculator out and you type into this function, making sure that the numerator is in a set of parentheses and the denominator is in a set of parentheses. So I go to my y equals x minus 5 in my numerator divided by x plus 1 in my denominator. Graph it. Once again, the graph does not show the asymptotes. So it looks like I have a curve in this region and in this region. This part of the curve has no intercepts. This part has x and y intercepts. Let me ask my calculator to find those. I'm going to hit second, calculate value. If I put 0 in for the value, it's going to give me the y-intercept, negative 0.5. So my curve here is not great. Let me pull this more like so. Still not perfect. Just going to ignore these horizontal and vertical lines here and say that this is -5. So I'm not doing it to scale just because it takes too much time, quite frankly. X-intercept, second, calculate 0. 0, x-intercept, roots all mean the same thing. I need to move it to the left of my x-intercept, which it already is. Hit enter. I need to move it to the right. And I am to the right. I know it because my y value changed sign to be positive. Hit enter. That's also 5. That's it for number 8. Number 9. Anytime you have a rational function, you're supposed to factor it first. The last problem was already factored. Our numerator is the difference of two squares. Factors into an x minus 2 and an x plus 2. Our denominator is simply an x minus 2. Cancel. We can divide the top and bottom by an x minus 2. As soon as you cancel something, that means that you have a whole. Take whatever you canceled, set it equal to 0, and solve it. So we have there's a whole at 2 something. To find the y value of that whole, we just found the x value. Take what's left of your equation. So what we have left here is y equals x plus 2. But we have a whole at some ordered pair. This is just a line. We're graphing a line that has a hole in it. When you first look at this equation, it looks like it's going to be some weird graph. Turns out it's not. It's simply a line with a hole in it. To find the y value of this hole, take what's left, which is x plus 2, put the x value that you have here in for x. So you put 2 in for x. So we have a hole at the ordered pair 2, 4. So to graph this, and when I say this, I'm talking about this is what we're graphing. This is the simplified version of this original equation. Simply graph this line and then put a hole in it. Y-intercept of 2, let me put my x and y-axis on here a little more pronounced. We have a y-intercept of 2, let's say that's right here. 0, 2. Our slope is 1, so from that we go up and to the right 1 or down and to the left 1. So it looks a little something like this. It's almost right. There's a hole at 2, 4. If I go right 2 and up 4, there should be a hole in the graph. To denote a hole, we will draw an open circle. We will label its coordinates 2, 4. So this is a line that has a hole in it. Our x-intercept we need to find. You can ask your calculator if you want. I'm not a chump, so I'm not going to. Put 0 in for y and get x by itself. You get x-intercept as -2. That's it for number 9. Once again, once you simplify it, you're just graphing a line that has a hole in it. Just is in disguise here. It's a transformer. It's in disguise, more than meets the eye. Number 10 is different than 8 and 9 because this resembles a parent graph. This problem requires no work whatsoever. I'm going to show some work just so you understand, but it doesn't require any work. The parent equation for this is y equals 1 over x squared, which hopefully you know looks like this. Has a vertical asymptote at x equals 0 and a horizontal one at y equals 0. So what do these numbers do to the graph? This 2 stretches it vertically by 2. If I stretch this vertically, it means that these curves are going to not be as close to the axes. It's going to take longer to get close to them. That's what happens if you stretch this kind of a picture vertically. If you shrink it vertically, it gets closer to the axes. Stretching it gets further away. This minus here takes this graph and reflects it over the x-axis. So at this point, we are further away from the axes than the parent, and we're reflected down. This minus 3 translates it to the right 3. If I have a vertical asymptote at x equals 0, and I translate it to the right 3, that means I have a vertical asymptote at x equals 3. If your equation resembles a parent, you have little or no work to do. Translate it to the right 3, so the vertical asymptote is at x equals 3. The horizontal asymptote, if you move it right 3, you'd never even know it. It's in the exact same spot. My curves take a little bit longer to get to the axes than the parent, so I'm drawing it away from it. And they are below the x-axis because it was translated, it was reflected because of that negative. That's what the graph looks like. Easy peasy. Oh, I got to find this y-intercept. There's no x-intercept because it doesn't cross the x-axis. You can use your calculator if you want. I'm not going to because I'm a man. Put 0 in for your x value. Negative 3 squared is a negative 9. So I got negative 2/9 is my y-intercept. Number 11, this does not resemble a parent in its current form. If you factor the denominator, which you typically always need to factor, it's going to factor into an x minus 3 and an x plus 1. Once again, we're getting lucky on this factoring. The lead coefficient is a 1. If it's not a 1, it's a whole ordeal you have to do. This does still not resemble any of our parent functions. So unfortunately, we have to use our calculator, and eventually we want to get to a point where we don't use a calculator. But currently, we're going to have to. We need to find the vertical asymptotes. There's no holes because nothing canceled. Take your denominator, set it equal to 0. Solve each of those little equations because you're going to take each factor and set them equal to 0. So we get vertical asymptotes at 3 and at negative 1. This is going to be a funky graph. Let me put those on here. Vertical asymptote at 3. And at negative 1. These are vertical, horizontal. Let's see if we got any of those. To find horizontal, you compare the biggest exponent in the numerator, and this as it relates to the variables, to the biggest exponent in the denominator. The numerator, technically, its biggest exponent is a 0. This is negative 5 times x to the 0, because x to the 0 is 1. The denominator is a 2. If the numerator is less than the denominator, we have a horizontal asymptote at y equals 0. So that's what we know. No idea what the curve looks like. Let me tell you what some of the options are. I'm going to erase all these. Could be over here in this region that it looks like this, or it could conversely look like this yellow one. It's one or the two. It can't be both. Here in the middle, there's several options, some of which may seem contradictory. Could be some type of a parabola up here or down here. Could also be, even though it's going to hit this horizontal asymptote, could be some kind of a curve like this. And then lastly, in this last one, it's either going to be a curve like this or like this. So those are your options. We don't know which one. There's different ways to test to figure out what it could be, but right now we're just going to use our calculator. Let me erase these. So I pull out my calculator, go to the y equals. My numerator is -5 divided by my denominator of x squared minus 2x minus 3 parentheses. So you can see here on the left we have this shape. In the middle it's some type of a parabola, and on the right we have this shape here. So let's draw those. Once again, the asymptotes don't show up on your calculator. Before I draw this middle part, I just want to ask what that y-intercept is. Second, calculate a value, putting a 0 in for x, which is going to give me a y value. 1.66, which is 1 2/3, which is 5/3. So maybe something like this. The y-intercept is about 1.7. That's it for that problem. Had to use your calculator because this does not resemble a parent graph. If it doesn't resemble a parent, use your calculator. Number 12, this resembles the parent. Y equals 1 over x squared. This times 3 stretches it vertically by 3. This minus 4 translates it to the right 4. Therefore, this graph that had a vertical asymptote at 0 is going to have a vertical asymptote at 4, because this 4 takes it to the right 4. So there are curves which would look like this and like this. Since we have this 3 here, it stretches it vertically, which means curves kind of are a little bit more away from these asymptotes than what they normally would be. Can't see this over here on the right because I don't have enough room. But it's basically the same. And I'll tell you what I do so I can see it. I'll just move everything over. I have this y-intercept to worry about. There's no x-intercepts. You can use your calculator or you can calculate it on your own. I'm going to calculate it on my own because it takes less time. IMHO. -4 squared is 16, so we get 3/16 is the y-intercept. I didn't label my vertical or my horizontal asymptote, which I need to. Done. Little to no work when you know what the parent is and it resembles a parent. Number 13. Put on my axes. Does the top factor? Why, sir, hope so. Two numbers that multiply to get -4 and add to get 3. How about an x plus 4 and an x minus 1? Denominator doesn't factor. Nothing cancels. This does not resemble a parent graph. So we're going to have to use a calculator. Before we do that, we want to find the asymptotes. Vertical asymptote, take your denominator, set it equal to 0. So x equals 0 vertical asymptote. Horizontal asymptote, compare n to d. In this case n is 2, which is bigger than d, which is 1, so there's no horizontal asymptote. If there's no horizontal, there could be a slant. Is n exactly 1 more than d? In this case it is, because 2 equals 1 plus 1. To find the horizontal, you take the numerator and divide it by the denominator. However many times it goes into it evenly, well, that's what the slant asymptote is. X goes into x squared x times. S goes into 3x 3 times. So I have a remainder of negative 4, which you can write as remainder negative 4, like this. Or you could also do plus negative 4 over what you're dividing by. We don't care about that though. We just care about how many times it goes into it evenly. You set that equal to y. So we have a slant asymptote at y equals x plus 3. Got the vertical one. Now we have a slant one. Y-intercept is 3. Slope is 1. So it looks something like this. And I want to move these words to this side. What does your curve look like? Here's what it could look like. Curve could be like this and this, or you could have something weird happening down in this region, like so. Some combination of those. At this point, it doesn't resemble a parent. We have no other way of knowing. I mean, there are ways of knowing, but we're going to use a calculator. My numerator is more than one term, so I put it in parentheses. X squared plus 3x minus 4, parentheses, divided by x. I forgot my first parenthesis here. We're going to watch a little bit of magic happen. Get your popcorn out, boys and girls. You're going to see some magic. Once again, without knowing where these asymptotes are, you would not really know how to draw this graph. So it's showing this is going to be part of our graph in here, and the other part's going to be here. As this graph goes left forever, it gets closer and closer to that slant asymptote. As it goes right forever, it closely and closely resembles the same slant asymptote. So once again, here's what it looks like. I got some intercepts I need to find. Something like that, and something like this. Didn't draw perfect, and I don't really need to. Well, this part right here kind of bothers me. I need to keep going to the left, and it looks like it's coming back to the right. That's not good. It's closer and closer and closer to the asymptote. What are my intercepts? I have no y-intercepts, but I have some x-intercepts. Second, calculate 0. I don't see my cursor. There it is. To the left, hit enter. To the right, I hit enter. I want you to guess. It's about -4. And then you see this weird thing. -2.5 e to -13. That means we're going to have a -0.1225, which your calculator is saying that's 0. So that is our x-intercept. It's -4, 0. Other x-intercept, hit second, calculate, 0. I need to move over to the right, so I gotta keep hitting right so I can get on this other part of the curve. There it am. To the left of that, hit enter. To the right of it, hit enter, guess. It's probably going to say 1, because that's the other intercept. So I got 1, 0. 14. The average speed v, which is velocity, of a certain particle in meters per second is given by this equation, where t is in times, or t is the time in seconds. For what value of t would an asymptote exist? Well, you take t plus 3, set it equal to 0, and you get t is negative 3. Part B, what is the value of v if t is 2? Simple. Just replace the t's with 2's. Two squared is 4. That's 2 times 4. 7 times 2 is 14. On the bottom, 2 plus 3 is 5. Top, 2 times 4 is 8. 14 plus 5 is 19. 19 plus 8 is 27. So we got 27 divided by 5. So velocity, you're unlikely to say 27 divided by 5 meters per second. You could say 27 meters per 5 seconds. If you put that in your calculator and divide it, you're going to find that it's 5.4 seconds. Pardon me, not seconds. 5.4 meters per second. Part C, use a graphing calculator to graph this function. Describe the appearance. Well, let's do that. My numerator, I have 2x squared plus 7x plus 5. This problem used t's. We're using x's. It makes no difference. Denominator is more than one term. It's got to be in parentheses. X plus 3. Hit graph. Can't see the graph very well. I need to change my y minimum. I saw just a little nubbin down there. Change it to a negative 20. Graph it. Looks like to me that there's a vertical asymptote in this region, specifically at t equals negative 2. And it appears that there's some type of a slant asymptote here. So part C says, using graphing calculator to graph this function, don't hate me because you ain't me. It looks something like this. Describe the appearance. There appears to be a vertical asymptote at t equals negative 3 and a slant asymptote at, how are we going to decide where this is? I don't like to guess. Let's just find it. To find the slant, let me scroll up here a little bit. I'm going to take the function, the numerator part of the function, and divide it by the denominator. However many times it goes into it evenly, that's my slant asymptote. How many times does t go into 2t squared? It goes into 2t times. 2t times t is 2t squared. 2t times 3 is plus 6t. Change the sign of each of those terms and then add. 2t squared plus a negative 2t squareds cancel. 7t plus a negative 6t is t. Bring down the plus 5. How many times does t go into t? Evenly. One time. Everything else is the remainder. It's left over. So my slant asymptote resembles y equals 2x 2t plus 1. Appears to be a vertical asymptote at t equals negative 3 and a slant asymptote at y equals 2t plus 1. And to be more specific, it doesn't appear. This is what's actually happening.